Hi folks, in this tutorial 7, I will put some ideas from tutorials 2 through 6 and do a problem that's a bit more complicated in the sense that it has both a revolute join and a prismatic join embedded in it. Uh, this is a playlist that I'm making for performing kinematics analysis in the 3D Experiences platform, whose built-in engine for DMU for kinematics is actually what is taken from the CATIA uh, V5/V6 DMU kinematics module. What I have here is a block which has an arm. The block is traveling down the track, and this arm is rotating on the top. And there are different ways of doing this problem, but the approach that I'm going to take is using segmented excitation in order to describe uh, the uh, the prescription of the motion of the arm and the block. So the arm and the block are moving according to this description. This is 10-second interval, and it shows you where the position of the arm and the block are as a function of time. And uh, essentially, what I'm doing here is taking ideas from chapters 2 and 3 of this text, which was not updated since 2016. Okay, let's go ahead and do that. Let me start with an assembly. So here is an assembly design. First, I will do the track. So let me right-click, insert, and 3D part. This is going to be my track. Okay. Uh, so let's make it. Double-click on this, and on that, for example, vertical plane, I will sketch. The track is made of this. See, that is made of this rectangle. Let me give some dimensions here. So this is going to be 1 inch, and this one I want to take to be 0.25. There we are. This is going to be my track. So exit, and I'm going to pad it by 11 inches. That's going to be the track. All the way to the top, right click, insert. I'm going to do the block now, insert the 3D part. And just so that I can have better bookkeeping capabilities here, I'm going to say this is the block. I add this prefix to the beginning and block. Okay, let's make it. So double click on that. On that vertical plane, we'll sketch a 1 by 1 rectangle, which is going to be square, obviously. There we are. Why don't I sure, exit and pad it by 1 inch. Okay, and just so it looks nicer, on the very top, I will sketch a little circle. Doesn't matter where it is. And let me actually give it dimension 0.25. Exit. And I'll make a pocket all the way through. Okay, good. So now you go all the way to the top, right click, insert, another 3D part. And this I'm going to call arm. Okay, so I add a prefix arm here. And arm, arm, exit, and let's make it. So on this plane, I will, well, let me actually get there, go to that part. And for example, on the XY plane, I will sketch. Where's that? Sketch. Why don't I draw something that looks like a propeller? So really doesn't matter. Okay, let me dimension from here to here to be 3 inches. Okay. Oops. So let me connect these two. I didn't realize that there was a gap there. That's okay. Can I make it coincident? Yeah. All right. Exit and be padded. Why don't I make this thing 0.2? So this is going to be the prop. All right. So, or the arm, all the way to the top. And now we're going to assemble these things. Let me actually fix the track. So on the engineering connections, fix the track. Okay, fix. Now I'm going to put this thing over there, and instead of making constraints, I'm going to make it with the snap. I'm going to use this snap option. So this point snapping to that point. Okay, good. There are no constraints that are created here. It's just that we snap the location. And then another one, snap this axis. Well, how about making, okay, how about making this axis and that axis, except that I'm going to move it up. Cancel that. Okay. Let me move this thing up. So manipulate, move this thing in the direction Z, so I can see it better right there. Okay. And why don't we go and create a joint? So this is fine. So let's go ahead and create the joints. Let's do this one is prismatic. So prismatic between, I'm going to use this option between this edge and that edge, this plane and that plane. And for the controlling entity, I'm going to use these side planes. Okay, good. All right, let's make a revolute between the arm and that block. So let's make another one. Revolute. All right. There are different ways of making it. For example, if I want to do this, this is going to be edge, edge, or axis, axis, plane, plane, coincident. And then we need an angle constraint. So we're going to do that. So I'm going to use this axis and that axis. Coincidence, so this plane and that plane. And for the angle, I'm going to use the vertical plane, one of the vertical plane of the arm and the block. So let's see now, this is the block and this is the arm. Okay, so we're going to use, for example, YZ plane of the, this is for the block and the YZ plane of the arm. Right now it's 0 degrees, and if I change this thing, notice that if I change it, it's going to start turning. Let me see. 30 degrees, 40 degrees. You can see that. So that's fine. It really doesn't matter. We don't want to check any contact. Okay, it's going to go there. So now we're going to, let me see. Now we're going to go to the mechanical systems design, create mechanical systems design, create a mechanism. Now this one, the block will go to the left. I don't want it to go to the left. I want to go to the right. So I just flip that direction. Okay, good. Now there's not much you can do with the rotation of this. It has to be done in the formulas or in the graphs if you have to change the direction. But that's okay right now. Now, let's go and check a few things. If you click on the mechanism manager, you see that it's got a green check mark. There is a fixed part, that's the base or the track. There is a prismatic one, length driven. There is here, and there's this arm which is angle driven. So that's fine, and you can always check it. If you click on this mechanism player, and if you drag this thing, this is for the prismatic one, and this one is uh, for the for the arm. So reset. So it's working. All right. Now we're going to go and create our physics. So basically, we go to mechanical system experience. All right. So I'm going to create two excitations. The first one is, for example, for the block. That means this has to be somehow given. So let's go ahead and make a first one. So segmented excitation. By the way, I'm going to call this thing the prismatic, or I'll call it block. How about that? Block. Okay, so the support is that command for the block, which is, I think this one was the block. Okay, and then to change these things, you click on it. Let me move this thing out of the way. Okay, so you left click on this thing, and the start is 0, the initial position is 0, okay, and end is the first segment, end is, let's check, end is 4 second, and the height is 8 inches, so that's going to be this. This is 4, and y is 8, and it's linear. Then another linear. So the way you do select, you select this row, and then you add. So there's going to be another row added. So it starts at 4 and 8. This thing out of the way. Then we check this. It's going to go to 6 and 8. So it's going to be horizontal line, 6 and 8. I don't like this thing. This is. Let me move this thing out of the way. Move this. Okay. This is sorry. What was that? 6. I believe it was 6 and 8. Yeah. 6 and 8. Okay. So 6, and this is going to be 8. Also linear. Good. Oops. Should be 6. You can see that? And then it's going to drop to 0 at 10. At 10. So you select that, you add. So this is going to be, then it's going to be 10 seconds, and this is going to be 0. So that's basically what you see here is this graph. Okay, good. Now let's go and do the other one. So this is fine. We just say okay. This one was a block, and then we add another one. We add another one, segmented. This one is for the arm, and the support is this other command, the one for the arm. And let's do that. So we have to input this curve now. At 4 seconds, 720 degrees. So end is 4. This is 720. and it is linear. Then up to 6 is going to stay at 720. So you have to select this entire row and then you say add at 6, 720, also linear. So that is this piece. And then it drops to 360 at 10 seconds. Drops to 360, so select this entire row, add, not there. So that's going to be 10, 360, also linear. So what you see there is this graph. Okay, very good. Let's go down here. We say okay. All right. So we have created two excitation. You can always plot these things. You put the cursor there. Well, after you create the scenario, you can do that. So that's fine. Just let's not worry about it right now. So we create a kinematic scenario. These two excitations are going to go there. We do it over 10-second interval, but let me make this thing 0.1, by the way. It's too much. 0.1. And then we say okay. I think now we can plot these. Yeah, we can plot these things now if you want. These are the two graphs that we created. All right, so in order to be able to plot these things to check, you have to be in the scenario, okay? I didn't have a scenario here, so now let's go ahead and compute. Okay, how do we check if this is right? So we click on the plot results. I didn't ask for anything else, but the commands are already there. So I say plot. So these two graphs better be these two graphs. Otherwise, there's something wrong. And if this is wrong, of course, anything that you generate based on that is also incorrect. Now, let's do a couple of things here. First of all, I'm going to go back to, let's plot the trace of this point. So for example, let's find out how this point, what is the path of this point. So you click on the geometric trace, you select that point. This 101 is based on the fact that I selected the time step to be 0.1. Over 10 seconds is 101 point. You say fine. There we are. And if you want to put this thing in the part, so what you can do is you can right click, copy, you go back here, let's paste it. Well, let's go back here and paste it. There we are. So yeah, so let's go ahead and find out where things are. I'm going to click on the animation. Let's go ahead to, let's go there. We're going to run this thing. Okay, so let's check a couple of things. So if you click on the play animation, notice that I can advance in time. So right now the point is here, but as you advance in time, so you can see that it follows that path, that trace. You can see that it stays on that. Let me do one more thing, and that is, suppose that you want to find the swept volume associated with the motion of this this arm. So you click on the sweep motion, swept volume, and you select that piece. Then you say OK. So that is going to be the swept volume. Now, if you once again, if you want, right-click, copy. You go to the assembly, right-click, paste. And let me change the, so I must have selected the block. Okay, I must have selected the block. That's why I got this. So let me actually go back and select the arm. Okay, so a couple of things here. First of all, On here, I can change the transparency properties, graphics transparency. Can I change that? Yeah, so that you can see what's in it. That's a little bit better. You can see that it's the path of the block that I got. If I wanted the path of the other fellow, I should have taken, let's check this. Yeah, so let me change the rendering here to find out where things are. Actually, you know what? Let me do this copy. Go back here, paste it. Paste it. Well, if I had selected the proper part instead of the block, this would have been the path, the swept volume associated with the propeller. In fact, you can see that if you right-click properties here and change the transparency, you can actually see the propeller is right there. So it's going to swoop these. All right, folks. So this is it. Good luck.